Okay, so now we proceed and solve this so that you have minus 13 plus or minus. You put these figures in the calc. So if you take your calculator, you will say 13 squared minus into brackets 4 times minus 1.4 times minus 15, close the brackets, equals 85. Get the square root of that answer. You get 9.2195. Then this one you divide by minus 2.8. Minus 2.8. So we now proceed. And when we proceed, we get that this will be equal to minus 13 plus 9.2195. You divide by minus 2.8, or minus 13 minus 9.2195. You divide by minus 2.8, minus 2.8. So this one will become minus 13 plus 9.2195 divided by minus 2.8. I'm getting 1.35, or minus 13 minus 9.2195 divided by minus 2.8 is 7.94. So those are the answers. So the question was asking us to say the break-even point. So thus, first break-even point is 1.35 units. 1.35 units. And second break-even point is 7.94 units. So that is how you get the answer to that. Are we together, Mohammed, up to that point? You should unmute yourself. Unmute yourself so that I can hear you.
Sorry, I was muted. Very much, sorry.
Yes, I could not hear you.
Yes, I am following it keenly, and I am with you. I am very fine with the quadratic equation, but it seems I forgot the content of the formula. Just one thing I wanted to ask about the quadratic equation formula from the beginning. Just when we say Q, the standard quadratic equation formula.
I don't know why I'm not getting you clearly.
Are you hearing me, or should
whether my computer is Kochini?
Mr. Kimani, are you hearing me well?
I'm not getting you clearly.
So let me.
I don't know why.
I was saying.
Good. Now I can hear you. Maybe there is something you have done. I can hear you now clearly. You are saying?
Yeah, I am now close to the microphone.
Yes.
I was saying I am very familiar with the quadratic equation, but it has been long. So I wanted to ask the content of the quadratic equation, which is Q equal to minus B plus or minus the square root of B squared, the total square root minus 4AC, total of 2A. Now I wanted to know where is our B in the equation?
Our B in the equation is this one. This one.
I think
So,
the Q without the square.
do you?
The Q without the square.
The one which has a value which is squared is the one that is A.
That is true.
And the one, maybe the general format of a quadratic function that y is equals to ax squared plus bx plus c. So in knowing who is your A, the one which has a square, that is your A. And that is what we had here, 1.4. That was our A. The one which does not have a square, but has x, that is our B, this one. And then the one that does not have x, it is our C.
Thank you so much. Thank you so much. I understood now. We can proceed ahead.
Okay, karibu. So the next thing is the level of output that maximizes profits. That maximizes profits. So we say
that process was 2 marks.
yes, 2 marks.
Okay.
But it also is the foundation for the second part.
That's true.
Okay. Now, for maximum profit, the differential of pi with respect to q should be equal to 0. Pi is the profit. Pi is the profit. So, how do we get pi? So we need to come back here and say the differential pi with respect to q is 0, and pi represents total profit. Represents total profit. So total profit, if you are looking for total profit, it is total revenue minus total costs. It is total revenue minus total costs. So from our other workings, we already have the equation for total revenue. Total revenue, we know it is this one. 0.3 q squared minus 5q. So we minus the total costs, which is 1.7 q squared minus 18q plus 15. So we open those brackets to get 0.3 q squared minus 5q minus 1.7 q squared plus 18q minus 15. This one, we put right terms together, we go back to the equation that we had. This will be minus 1.4 q squared plus 13q minus 15. That is the profit function, which we had earlier. This is our pi. That is our pi. So the differential pi with respect to q, when you're told to differentiate, what you do, you take this power to, you multiply the function here, minus 1.4 q raised to power 2, you minus 1. You minus 1. Then you come to this one, 13q. When it is 13q, it is q raised to power 1. So you take 1, you get 13q raised to power 1 minus 1, that way. Minus this 15. When it is just 15, it is 15q raised to power 0. So you take that to power 0, so that you say 15q raised to power 0 minus 1, that way. And then this one opens up as minus 2.8 q raised to power 1 plus 13 q raised to power 0 minus 0. This becomes 0. Any number multiplied by 0 is 0. So this proceeds to become minus 2.8 q plus 13. Because this one, a number raised to power 0 is 1. And remember, this one we are saying it is equal to 0. That is what we have said. So if that is equal to 0, then that means 2.8q is equal to 13. And it then means that q will be 13. You divide by 2.8. 13, you divide by 2.8. That gives you 4.64 units. So that means if you want to maximize profits, you must produce and sell 4.64 units. Is that okay?
Yes, yes.
Good. So that is the first case. So let's look for another question. So I want us to go to the question of May 2021. Question 1B. May 2021, question 1B. So the question says, Compu World Limited assembles and sells computers. The company estimates that if it optimally assembles computers, it could sell between 1,100 and 2,000 computers per month, and the monthly revenue in thousands of shillings over this range of sales could be presented by the function R is that, where R is the monthly revenue, X is the number of computers sold. The company estimates that its marginal cost in thousands of shillings could be presented by the following function. MC is given by that, where MC is the marginal cost, X is the number of computers assembled. The fixed cost of the company amounts to shillings 100,000 per month. If it is assumed that all the computers assembled in a given month are sold within the same month, so you are required to compute those items. Just a minute. So the first thing, we are given a total cost. So when you are given total costs, or you are required to get total costs, it is the integration. That is called integration of the marginal costs. Of the marginal cost with respect to Q. You integrate. Integration is the reverse process of differentiation. So to integrate that, you take the marginal cost function, which is given as 200x squared. 200x squared. So we are integrating this function, 200x squared minus 200x plus 400 with respect to Q. So to do that integration, this is what you do. So we get 200x squared. You add back 1, you divide by the new power, 2 plus 1. Integration is the reverse of differentiation. Hiyo swali lingine tumejibu, it was differentiation, where we were subtracting and then multiplying here. We were multiplying and then we would subtract. So to do the reverse,
now we add, then we divide.
You are okay?
Yeah, I'm okay. I'm okay. Now for differentiation, we subtract the square and then multiply it. Now we subtract. Now we add it for integration. Then we divide.
Sorry, I'm not getting you. I don't know whether it's your side or my side.
No, I was telling you. It is very clear for differentiation.
Then
you subtract this square. You subtract 1 from the square, then you add. No, you multiply. And this is the opposite. So now you add, then you divide.
Yes, because it is opposite.
It's opposite. Yeah, I understand.
Is it okay?
Yeah, I'm fine. I'm fine with it.
Okay. I don't know why I'm not getting you clear. But I think I've just said
I'm fine with it, yes.
Let me try to adjust my monitor. Just a minute. Try to see. Able try again. I see now that I can hear you.
Yes, Mr. Kimani, I am fine with it. I'm okay.
You are fine now, eh?
Yes.
Good. Now I can hear you. I have brought my speaker also closer to me. Okay, so we can proceed then. And I was saying that this is opposite. The process is opposite of what we normally do. So now when I come here, I'll say minus 200x. Now, I have told you if a number is written like this, it is already raised to power 1. So you raise to power 1, then you add back 1, and you divide by the new power, 1 plus 1. That way. Then we come to this one, plus 400. When a number is like this, it means it has x, which is raised to power 0. So it is 400x raised to power 0. You add back 1, divide by the new power, which is 0 plus 1, which is 0 plus 1. Then you add the constant of integration c, the constant of integration c, and then from there you come and say 200 x raised to power 3, you divide by 3. This one, it will be 200 divided by 2, it will be 100x squared plus 400x. Now, when you are dealing with the cost function, the constant of integration c is the fixed cost. It is the fixed cost. So in our question, the fixed cost is 100,000. And because the equation is in thousands, so you just put 100. So the 100 is the fixed cost. So we have answered the first requirement, which was total cost. The second one is total profit. But before you get the total profit, you need to bring the total revenue function. Total revenue, it is already given in the equation as in the question 1,000x. We are given 1,000x minus 200x squared. So that one is already given. We don't require to compute like we did with the other one. Then total profit, tumesema in the other equation that if you are looking for total profit, it is total revenue. It is total revenue minus total cost. Total revenue minus total cost. So my pi will be, I take this revenue function, 1,000x minus 200x squared. Then I say minus the cost. The cost is 200x cubed out of 3 minus 100x squared plus 400x plus 100. Are we okay up to that point?
Yes.
Okay. So we proceed now. And now I open the brackets. When I open the brackets, I will say that pi is equal to 1,000x minus 200x squared minus 200x cubed out of 3 plus 100x squared minus 400x minus 100. Minus 100. So I put like terms together and I get 1,000 minus 400x, that would be 600x. 600x minus this 200 square plus 100. So that would be minus 100x squared. Then minus 200x cubed out of 3. And then this 100 is on its own. Minus 100 is on its own. So that is the profit function. So that is the total profit function. The next requirement is optimal monthly output. Optimal monthly output is equal to units at maximum profit. Units at maximum profit. If you are told to get optimal output, it is the units at maximum profit. So I've just told you a while ago that for maximum profit, the differential of pi with respect to q should be equal to 0. The differential of pi with respect to q should be 0. That is, if I get the differential with respect to q of, I take this function, 600x minus 100x squared minus 200x cubed out of 3 minus 100, I should get it as 0 when you differentiate. I've told you integration is the opposite of differentiation. So now we are differentiating. So this one, it is 600 raised to power 1. So you take 1, you multiply 600x raised to power 1, so you subtract 1. You subtract 1. So that now when we will need to integrate, we will add back 1 and divide by the new power. Then I come to this other one, minus 100x squared minus 1, that way. Then I come to this one, 3 into brackets 200x cubed out of 3 minus 1. Minus 1. Then this one, I have told you, it is having x which is raised to power 0. So it will be 0, 100x raised to power 0 minus 1. And this one you're saying should give us 0. Should give us 0. So this becomes 600x raised to power 0 minus 200x raised to power 1 minus this will cancel, so 200x squared minus 0 equals 0. So this one, when you simplify further, in the back here has 600 minus 200x minus 200x squared equals 0. Equals 0. So, if that is okay, this one, as I told you, when it is raised to power 2 is a quadratic function. It's a quadratic function. So you proceed down there and say, using quadratic formulae, now we are looking for x. So we will say x is equals to minus b plus or minus b squared minus 4 is c. This one, you get the square root. You divide that by 2a. You divide by 2a that way. Now, the other one, we had put q here because you are looking for q. This one we have put x because we are looking for x, but this bit remains the same. This one is always the same. So now in my equation here, my b now is this minus 200. So minus 200 becomes positive. So you'll have to put 200 there. Plus or minus 200 squared minus 4 times a. A is the one which has a square. That is minus 200 times c. C is the one which does not have x. This one, 600. 600. This way. You divide by 2a. 2 times minus 200. 2 times minus 200. So with that now, this becomes 200 plus or minus, we get the calc and solve that. The same 200 square minus, open the brackets, 4 times minus 200 times 600, close the brackets, equals 200 square minus, open the brackets, 4 times minus 200 times 600. Yeah, get the square root of that answer is 721.11. 721.11. Now this one, you divide by minus 400. So this becomes 200 plus 721.11. You divide by minus 400, all 200 minus 721.11. You divide by minus 400. So we solve that now and get 200 plus 721.11. You divide by minus 400 and get minus 2.3. All this other one is 200 minus 721.11 divided by minus 400 is 1.3. You get 1.3. So sasa, now that this one cannot be, units cannot be negative, so we disregard this one. So we take the positive as 1.3 units. So that is the optimal optimal output. So from there now, we are told to get maximum profit. So maximum profit, you now substitute that in the function that we had for the profit. The equation that I have, which was for the profit, and I think it was 600x, so it is 600 times 1.3. Then this was minus 100 x squared, so times 1.3 squared, minus 200 times 1.3 cubed, divide by 3, minus 100. Minus 100 to go on your pro function. So you just substitute there. So that's 600 times 1.3 minus 100 times 1.3 squared minus, open the brackets, 200 times 1.3 raised to power 3 divide by 3, close the brackets, minus, open the brackets, 100. So I'm getting 364.53. Okay, are we good up to that point?
Yes, we are good. But I'm now grasping it because it has been long since I have seen this, questions. But if I get the textbook, the study book, I believe I'll be fine with it. 2 or 3 other examples, I'll be fine with it.
Yes, it will be possible. It will be possible. You will get more practice. Let's do another one. Let's still do another one. November 2020, question 1A. November 2020, question 1A. November 2020, question 1A. So the question reads that a potential investor in the production of a new type of organic fertilizer estimated that the demand function of the product to be average revenue is 150 minus Q, where AR is the average revenue in thousands of shillings, Q is the output in tons. The investor estimated the variable cost per unit ton associated with the production to be VC is equals to Q minus 285 in thousands of shillings. The farm's cost when not producing any output is estimated at 8750,000. So you are required to get the profit function. So as I told you earlier, the first thing is to get the total revenue. So total revenue will be given as average revenue times units because here what you have been given is the average. Average is the revenue for 1 unit. So this becomes 150 minus Q, you multiply by Q. And this will be 150Q minus Q squared. 150Q minus Q squared. That is the total revenue. Then total costs. Total cost, you know, it is usually given as a variable cost plus fixed costs plus fixed costs plus fixed costs. So this one, the variable cost is Q minus 285. And this variable cost is per unit. So you must multiply by the number of units because variable cost changes as the units change. Now plus the fixed cost. The fixed cost is 8750. And this opens up as Q squared minus 285Q plus 8750. That is the total costs function. So with that now, you proceed and tell us that total revenue is equal to, sorry, not total revenue. We are now looking for total profits.
Profit.
We are now looking
profit.
for total profit is equal to total revenue you minus total costs. Total revenue minus total costs. So total profit is the one we are calling pi. So our revenue is 150Q minus Q squared. Then you minus the cost here, Q squared minus 285Q plus 8750. So opening these brackets, you get that pi is equal to 150Q minus Q squared plus 285Q minus 8750. Minus 8750. So this one becomes 150 minus plus this one. If you take your calc, you will find that it is 150 plus 285. Get 435. 435Q. This one becomes minus 2Q squared minus 8750. 8750. So that is the profit function. Now from there, the level that maximizes profits. You say for maximum profit, the differential of I with respect to Q should be equal to C. That is, we differentiate this one now. The differential with respect to Q of 435q minus 2q squared minus 8750 is the one we are saying should be equal to 0. So sasa, this one, because it's raised to power 1, it will be 1, 435q raised to power 1, you minus 1. Then this one, it is raised to power 2. So you take 2, and then you have 2q, 2 minus 1. This one, it has q which is raised to power 0. So you take 0, then you say 8750q, 0 minus 1. It should take you to 0. It should take you to 0. So when it takes you to 0, you are left with 435q raised to power 0 minus 4q raised to power 1 minus 0, that becomes 0. And when you further simplify, this one, a number raised to power 0 is just 1. A number raised to power 0 is just 1. So this is left as 435 minus 4q is equal to 0. And then it means that q should be equal to 435. You divide by 4. Q should be 435. You divide by 4. And I'm getting 108.75 units. So that is the one that maximizes profit.
Very clear.
That is okay, eh?
Yes.
Good. The next thing we are told is the output that
break even.
Yeah?
Break even output.
Good. So you will need to say that at break-even point, we had said total revenue is equal to total cost. Or there is something else that we normally say, all profit is equal to 0. All pi is equal to 0. At break-even is the point at which the business is not making profits or losses. So that is, you now take this equation that we have been having for the profit. This is the equation for the profit, 435. So we are saying 435q minus 2q squared minus 8750 is equal to 0. Is equals to 0. So once again, that becomes a quadratic function. So you say using quadratic formula, which now we know so well. So I think I can just substitute straight. Is that okay? We have written that formula twice. So minus b, our b is this one, so it will be minus 435 plus or minus 435 squared minus 4 times a. A is minus 2 times c. C is 8750. 8750. So this one, it is square root. You divide all this by 2 times a. A is minus 2. So this becomes minus 435 plus or minus, if you take your calc, you'll be able to argue 435 squared minus, open the brackets, 4 times minus 2 times 8750. Square root of that is 509.14. 509.14, and this is minus 4. So this becomes minus 435 plus 509.14. You divide by minus 4, or minus 435 minus 509.14. You divide by minus 4. You divide by minus 4. So minus 435 plus 509.14. Divide by minus 4. I'm getting minus 18.535, or minus 435 minus 509.14 divided by minus 4 is 236.035. So those are the answers that we should have. Good. So we are still okay, eh?
Yes, I'm fine.
Good. Maybe we can have another one, the last one, which is a question of November 2019, question 2A. Yes. November 2019, question 2A. So November 2019, question 2A. The question says that the profit function for a given company is given as that. So we are told, number one, to get cumulative profit in break-even time interval. So the first thing is to get the break-even point. So we begin again by saying that at break-even point, total revenue is equal to total cost, or profit is equal to 0. Total revenue equals total cost, or profit is equal to 0. That is pi, that is 10x minus x squared minus 5 is equal to 0. Once again, this is a quadratic function. So we will proceed and say, using quadratic formula, then x will be minus b. Minus b is this 10. So it is minus 10 plus or minus 10 squared minus 4. A is this one, minus 1. C, and C is this one, minus 5. Minus 5, that way. So you divide by 2 times minus 1. So this becomes minus 10 plus or minus. You put the figures in the calc. You put the figures in the calc, and that will give you 10 squared minus 4 times minus 1 times minus 5. You get the square root of that. I'm getting 8.944. So this one, you divide by minus 2. So you proceed and say x is minus 10 plus 8.944, which is divided by minus 2, or minus 10 minus 8.944, you divide by minus 2. So x is equals to minus 10 plus 8.944 equals, I divide by minus 2, I'm getting 0.528, all minus 10 minus 8.944, you divide by minus 2, it is 9.472. So these are the ones that we call the interval. It is what we had called first break-even point and second break-even point. So that is the interval. So when you're told to get the cumulative profit, cumulative profit, it is the integration. It is the integration from the lower limit. The lower limit is 0.528 to the upper limit 9.472. And what we are integrating is this function 10x minus x squared minus 5 with respect to x. This one is called definite integration. This one is called definite integration. When you get the book, you will check definite integration. The other one we did was called indefinite, or it's called indefinite. Haikuwa na limits. So this one has limits. So this one opens up like this. You just integrate what we say in kawaida. So 10x, which is currently raised by 1, you add back 1, you divide by the new power, 1 plus 1. Minus x squared, currently raised by 2, you add back 1, you divide by the new power, 2 plus 1. Minus 5, which is currently x raised power 0, you add back 1, you divide by the new power, 0 plus 1. Then you say in the range. In the range, you draw a stroke like that one. That stroke is read in the range. In the range of 0.528 and 9.472. That is how it is read. And then this one proceeds to become 5x squared minus x raised power 3, you divide by 3, minus 5x, again in the range of 0.528 and 9.4272. No, 0.472. So what you do from there is you now take the higher value. You say 5 times 9.472 squared minus 9.472 cubed You divide by 3 minus 5 times 9.472. So you take the higher value that way. You substitute kila mahali kuna x. Then you minus the lower value. The lower value, you substitute it there. So you say 5 times 0.528, which is squared, minus 0.528 cubed. You divide by 3, minus 5 times 0.528. So the higher value is the one you start with. You substitute in the equation, then you subtract the lower value. The lower value. Okay, so you put these figures in the calc. So times 5 minus 9.472 raised power 3 divided by 3 minus 5 times 9.472. So this one is becoming 117.9618 minus, if I go to the other one, 5 times 0.528 square minus 0.528 raised power 3 divided by 3 minus 5 times 0.528. I'm getting minus 1.2951. So the total answer will be 117.9618 plus 1.2951. The answer is 119.2569.
That's the cumulative profit.
Yeah, that's the cumulative profit. The profit between, maybe for illustration purposes, what we are talking about ni kitu inakaa namna hii. Hapa ndio 0.5, na hapa ndio 9.4. So function inakaa hivi. So tunatafuta hii region. So
that's very clear.
When you substitute 9.4, this one, it gives you the total area from here, from 0 all the way to here. When you substitute this 0.5, it gives you this area here. So for you to be left with this other one, then you subtract here. Have you visualized it?
Very, very, very easy to understand.
Good, 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 good. So finally, tunaulizwa the best time to end. Now, best time to end is at optimality. Best time to end is at optimality. So best time to end is at optimality. Optimality. That is when differential profit with respect to X is 0. That is the best time to end at optimality. So the differential of with respect to X of 10x minus x squared minus 5, we are saying should be 0. So this is raised power 1, so it is 10x 1 minus 1. This is raised power 2, so it is 2 x squared minus 1. This is raised to power 0, so it is minus 0. 5x 0 minus 1 should be equal to 0. So when you open the brackets, this becomes 10x raised to power 0 minus 2x raised to power 1 minus 0 is equals to 0. And this then chooses to become 10 minus 2x is equals to 0. And therefore, x must be 10 out of 2, which is 5. So finally, you are told the profit based on our answer. So maximum profit, you now substitute this 5 into our profit function, this one. So 10 times 5 minus 5 squared minus 5. So if you put the figures in the calc, that will be 10 times 5 minus 5 squared minus 5 is 20. Now what you can see is that the examiner has the tendency of repeating the questions in a very similar way.
Yeah, I'm seeing almost look-alike.
Yeah. So if you can practice a few of them, then you'll be good to go with that topic. Yeah. So when we meet to, in the next lesson, now we will discuss something else. But the way to go is you first of all close the book and try to do these questions on your own. And once you're able to answer them the way we have answered, you can now do some more. You will have gotten the concept.
Yeah, I understood. But is this how the topic of the function questions come usually?
Yes, that's how they come.
Yeah, it is manageable. If I try to solve this, like 50 questions of this will be fine for me. I'm very good student when it comes to repeating and understanding, especially in mathematics. So
Yes. Yes, that
I
is.
hope today I understand it was a very long day for me, just like yours. I woke up at 4 a.m. so I am still in the office. If you can see me, but from tomorrow I think we'll be having at 8 a.m. in the morning.
Yes.
Yeah, so I'll be fine, and still I will not get the books by tomorrow morning. I understand, because maybe I will
because I was recording the lesson. Let me edit, then we talk over the phone.
Thank you so much.
Karibu.